Okay, sorry, yeah. Now, sorry, I've just got to go back over what I've written down here. Now, you're saying, can you just remind me what it was you said about the government wants to reduce the values, is that correct?
Oh, no, what it is that RBE means that you're comparing different kinds of radiation to see which one is more powerful than another.
Right.
Because there's no benchmark. It's all relative. You have to compare one against the other. And you get, if you compare one against this, against this, against this, against this, and you get a rough idea of what's going on, right? With what RBE means. And you can do that for different kinds of radiation. And there's a particular kind of radiation called tritium, which is radioactive hydrogen. And that hydrogen gives off a beta radiation electron. And it's quite dangerous, but they don't recognize it. Because radioactive hydrogen is very, very common, it's given off by all nuclear processes, and it's given off by all military processes. There's a big kudos on the government to keep the pressure on, to keep the RBE for tritium very low, and that's what they're doing. I work for the government committee on tritium, which is an internal emitter par excellence, and they said, woof, that should be increased, the danger for tritium should be increased threefold, but the government refused to accept it.
I guess what I was trying to get at was, we're concerned about the level of radioactive waste that's going in. It's described as low level. And is there a possibility that at some point the government will say, well, actually that is very low level and we're going to increase what we call low level? Is that a possibility?
Yeah, well, yes. By the way, when I say tritium, one of the most important radionuclides which will be involved in any low-level dumping here will be tritium. Because it's radioactive water. And radioactive water is by far the most common radioactive substance which is found in landfill sites throughout Britain. And it's the biggest problem, in fact. So this RBE for tritium isn't just a theoretical thing, it is right up your alley. And I've written articles about this, about the dangers of radioactive tritium. And you'll find this funny, Richard Wakeford, our common ME, who is the editor of a journal, and he's published my article. Because he thinks that there are dangers from tritium as well. Sorry, I'm aware that I've said it maybe too much, and it's very complicated. Shouldn't maybe apologise, but it is tricky. I understand that, and you have my heartfelt sympathy about trying to grasp this. All I can say is that if you go away from this meeting hall tonight thinking, there are more problems with low-level radiation than I thought, and you've got, essentially, particularly with tritium. And perhaps at some other time, next year sometime, I could come back and I could talk to you for an hour easily about tritium, just in case you haven't got enough already. My colleagues call me Mr. Tritium.
Chris?
Well, it may be connected with that, but the studies that you've shown around European nuclear power plants, are the findings at all applicable to our situation here near a radioactive waste dump?
Yes, because the most important radionuclide put out by the power station is
Yeah.
yeah, it is. And carbon-14, which is the second one. And carbon-14 and tritium are very similar because they're both heavily involved in life. We need carbon, we need hydrogen. And they are avidly taken up by our bodies, both carbon and hydrogen. And in fact, tritium is maybe 10 times more important than carbon, but the two of them together are important. The thing about tritium is that it goes into our foodstuffs, and we can contaminated foods, and we breathe it in when it gets into the air as radioactive water vapor. And there's not much you can do with that. And you get doses from both breathing it in and it from landing on your skin, because it goes right through your skin, and from eating in food. So it's a rather nasty substance altogether.
Another question.
Considering that low-level waste is already being dumped in the dump, what can we do to lessen the effect on us? I mean, should we be campaigning to contain it in a different way, or, you know, I mean, it's here as a reality at the moment.
Yes, I know. You could put pressure on the government to say that you want more effective physical safeguards. It's called the technology. More robust packaging. Don't use concrete, use stainless steel. Roughly speaking, 1,000 times more expensive. But,
At the moment, they're using plastic bags, I think.
well, that's crazy. The thing about water, is there anybody here who's an architect? One of the things about architects, they tell you in architecture school, is that there are only two things where water won't go through. One is stainless steel and the other one is glass. Otherwise, water will go through anything. And any of those people who go rising down to their houses will heartily agree. And it's true. Water is an amazing substance. It just goes everywhere. And that means it will go through plastic bags like nobody's business. And it goes through everything, except for glass or stainless steel. Glass is good because it shatters. So you need steel. Not just ordinary mild steel, you need stainless steel. And you not just a quarter of an inch thick or a centimetre thick, you need about 4 or 5 centimetres thick.
It's going to be too expensive, isn't it?
They will say that. And you will say, well, the health of my children is more important than your concerns about cost.
Also, I think I'm right in saying that they take the water out. I'm not entirely sure about this, but I think they transport it to the Bristol Channel and let it into the sea. Right?
No, they don't. They reuse it on the site.
They concentrate it. It's even worse than that.
Yeah.
They
Worse,
reuse it.
Yes, but that was linked to my question. They do something that they call stabilization and soil stabilization.
I don't know about this.
Is that a viable way of dealing with something? that
Taking
emits-
water out of soil is probably a good idea. It is, and that answers your question further back. I'm going to raise people's hackles by saying I think that putting radioactive water in the sea is a good idea.
Why?
The reason is that, and Greenpeace will, and Friends of the Earth will wrap my knuckles for saying this, is that because the dilution factor involved in putting a small amount of radioactive water into the huge amount of water in the sea is zillions to one. So there's very, very strong dilution. And as long as it's out in the middle of the sea somewhere, not just on the beach or anything like that, then I would find it difficult to argue against it. You may say, well, I'm not a very strong environmental scientist. Well, I think I am a strong environmental scientist, but I'm also a realist too. And if we've got real problems, I try hard to look at realistic solutions to them. And taking the water out of soil and putting it into 100 miles offshore in the Atlantic Ocean, well, I wouldn't have problems with that. For example, the power stations in Britain, they pump vast quantities of tritium into the sea. They do?
That's why they're located on the coastline.
Exactly. Partly that.
Partly.
It really has got to do with the heating, the cooling effect of pumping seawater in. But another one is to get rid of the tritium. It's very true.
Question over there?
If I could just ask the dumb question of the evening.
No, there's no questions are done.
I wasn't here at the start, so I apologise. I didn't necessarily get the gist of your role within government. You actually, are you in an advisory role to the government at times? Or
I'm retired now,
Right.
but in the past I worked for civil service for about 20 years or so. And I explained that I was a secretary to a government committee, ministerial committee, set up to look at questions of radiation risks from the stuff that gets inside you.
My question is, what optimism do you have?
What?
What optimism do you have that you can change the mindset of government in terms of the risks environmental to people, to animals?
Oh dear, that's a loaded question, that is. If I was to be brutally honest and frank with you, I would say one thing, but I'm going to be slightly hypocritical and say, keep up the struggle. Keep it up. Because if ordinary people don't stand up and say, no, I'm not having it, we're not going anywhere. I'm an executive member of CND, which is campaigning against nuclear weapons. And they've been at it since 1959. And they haven't got very far. But that's no reason for not keeping on. And I strongly support their efforts. Just because they haven't had a very good track record in winning against the government doesn't mean that they should give up. So my message to you tonight is, you're on the right side. You've got science on your side. Keep on pushing against the government. They know they're wrong. I know many of the government scientists, and they always put their eyes down when they see me. I know I'm right. I can sleep at night.
John?
I've got a question about the natural background radiation. I think you gave us an average figure, but isn't that rather variable? We've got granite areas,
Oh, yes.
places like in the
Yeah,
Bermuda.
very much so.
So what's the variability of that? And doesn't that give us a large database for doing epidemiological studies on the effect of low-level radiation or the incidence of various cancers and so forth?
Just so that everybody else knows where what's your first name?
John.
Sorry?
John, where
John,
John's
John.
coming from, is that I gave figures for background radiation which were averaged across Britain. It's a bit difficult, and I was trying to give you a flavour of it, but in more detail, hey, I can give you a lot more detail. Where's the person who's, do you want more detail? Areas like Cornwall and the Grampians near Aberdeen up in Scotland, they have a lot of uranium in the soil, and so the radon produced by that uranium contributes to higher doses in those areas. And the people in Cornwall, for example, some of them can get quite high levels of radon in their houses. The thing about radon is you can actually do something about it. One of the few things you can do something. You can put in a sump pump in the basement to suck out air from the underground area in the house. And that negative pressure takes the radon out of the house, effectively speaking. It doesn't bubble up upstairs. You can do something about it. There's another thing about radon, and that is that it doesn't fit our dose risk paradigms very well. External radiation does, but radon is weird. We haven't got a good handle on it. Our risk estimates, say from population studies, and our risk estimates from cell studies don't match up. And we don't know why. That's the best way of putting it. So when we talk about low-level radiation, I tend to talk, I'm on sure ground, but I talk about external radiation, X-rays or gamma rays, rather than the stuff you breathe inside.
So the background natural radiation is mainly from radon, rather than from direct irradiation from anything.
Well, do you remember that? See if I can find the slide. Um, this is different. Slide sort, here we go. Here we go. How do I show the slide? God almighty. Does anybody know how to just show one slide and not show from the start? I know how to get it from the
You
start.
probably read that one.
What is this one? Ah! There we go. Did it. Hey! God, it gives you a great feeling when you actually manage it. There we go. Shows you that, as I mentioned, about a third of our background radiation, 20 plus, that's 37, comes from external radiation, and about 2/3, that's what, 62%, comes from internal radiation. A lot comes from inhaling radon. On average, but the average conceals variations. Indeed, for people living in this area, background radiation is roughly speaking about 2 millisieverts rather than 2.7 on average, because of the fact that our radon levels here are quite low.
Have any studies been done on changes to the background radiation, but if you're sort of in areas that have higher possible internal radiation, and does that have a greater impact than maybe increasing the external?
Yeah. Now that I know how to do this, view, slide sorter. Just think you can take a copy of this home and play with it yourself all night. Background radiation, yeah. Here we go. Wrong one. Oh, and I thought I had it done right. Slide sorter. And I thought I had it, and I didn't.
Click slideshow on the top bar.
Sorry?
On the top bar, click slideshow. And then to the left.
There. Thanks. Thank you, whoever he was. Yeah, this is what Waller and Muster did. They studied radiation areas with high natural background radiation. And they compared that with other areas of normal background. And they compared the two, and they found higher risks in the higher background.
Did they compare the different types
Oh,
of
yes.
background radiation, and it was
Very
a
much so, yeah.
greater impact if it were
Yep.
internal?
Different areas had different kinds of radiation. It's a huge study. It's about 46 different, it's a meta-study of about 46 different studies. So they did their homework on this.
I have a question, two questions. The people orbiting in spacecraft, are they receiving radiation from onboard equipment or from the cosmos?
Cosmos.
Yeah. And in
And the sun.
Yeah. Well, in our particular case, we're receiving a large quantity of building rubble and that type of thing from former power stations. And there's a certain amount of medical waste that's radioactive, and radioactive waste from industry. And I think one of the local concerns is that it's all being put into one landfill site, like a potpourri. And I wondered if there are any studies of mixing it up.
With hazardous waste.
With hazardous
mix.
waste as well, yes, because in fact it's only classed as hazardous waste, the radioactive waste we're getting. They say it's not high enough in radioactivity to class it as radioactive waste. It's still, below the threshold that comes under hazardous waste.
No, I'm not aware of any studies of a potpourri, as you call it. My feeling, although I'm maybe putting words in there, what they're saying is that there's a lot of rubble, and they're hoping that the external gamma rays will be mitigated by the large amount of rubble that's there. There was natural shielding will go on. And I'm not really worried about the external gamma rays. I'm more worried about the internal radiation from the radionuclides which escape the soil. I'm more worried about that. Plastic bags aren't really good enough. There have been studies by the Environment Agency in the past, when it wasn't so friendly to the government, because there were quite a few years where the government wasn't pro-nuclear. From about 1995 to about 2004, the government were determinedly neutral on the issue, and that meant that the environmental agencies actually could put out decent reports without worrying about paying their mortgage, being brutal about it. And there were some studies about tritium escaping from landfill sites. There are consultants who would do some work in this area, I'm sure, if you asked them. Dig that up. I mean, I don't mean literally, I mean figuratively. Go back to the original reports back in the mid-90s and figure out what they said about the problem of tritium in landfill sites.
I understand that we shouldn't be getting radioactive water of any kind, but is there the danger? I think
you don't have to get it, it's there automatically.
It's there already, yeah. Because I understand from construction of the dump, they're allowing water level above the waterproof membrane they've constructed. I think the water level can be about 3 feet a metre, something like that, and then they siphon it off into a sump. This is the leachate. This is what they did propose, taking to Avonmouth and dumping it at sea, but now they're treating it on site and solidifying it.
In what?
Well, I think they're using fly ash from coal-fired power stations.
Sorry, I'm not following this.
Yeah.
How did they solidify it? In concrete?
Well, no, I think they're using fly ash from coal-fired power stations.
Into a slurry of
Into
kind?
some sort of slurry that sets, I think, rather
Like concrete?
cement. Yeah.
Ah. And what did
And
they
they're
do with
using that to stabilise the landfill, I believe.
Well,
This was because there's an awful lot of criticism about taking it in tankers to Avonmouth and dumping it in the sea.
I have to say that dumping it in the sea is a better option.
But of course, you could go to the east coast, which is much closer than Avonmouth and Bristol Channel. So a lot of the argument about our dumping is over the distances involved in the road transportation of the waste.
Yes, I can understand that. The thing is that putting it into fly ash and then putting it into some sort of concrete slurry, the problem's still there. The thing about tritium is that it gets everywhere. It has this unique property of finding any material which is hydrogenous, which contains hydrogen, which includes you and me. 2/3 of our body consists of water by weight. And all plants, all earth, all material, all biomass, all biota contain lots and lots of hydrogen. And if you still have the tritium around, it gets into that biota willy-nilly.
And there's nothing to stop the rain from just going through it anyway.
Yes, exactly, yeah. Tritium has got this property called an exchange mechanism. Let me tell you, it'll put the frighteners on you. If if you remember nothing else, remember this about tonight. All atoms are promiscuous. They swap with other people's atoms. So that means if you have a water molecule here and say an alcohol molecule here, and they both have hydrogens, they'll swap hydrogens. And it takes 10 to the minus 13 seconds to do it. That's an incredibly short period of time. And it happens all the time. All atoms do this to an extent, but smaller atoms do it much more commonly than big atoms because they are small. And guess what is the smallest atom there is? Hydrogen, yes! Yeah. It swaps merry-go-round. It is just all. And if you have one which is a hydrogen atom which is radioactive, which is what tritium is, it goes everywhere. So the radioactivity, in laboratories, for example, they had to basically close down, but more often have to just close down the laboratory because it's just everywhere. And you couldn't go into the building without becoming contaminated yourself. That has happened. Give you a little example of this. When I was a student at Imperial, doing my doctoral work, we had to put radioactive tritium into water, into rivers, tiny amounts, as a tracer, to measure how fast the river ran, and whether it was affected by rainfall or whatever it may be, or we were testing. And one day, you had a guy called Bunny who was a bit of a wide guy. He was really funny, a real lark. He said, well, I'm going to measure the tritium levels and give you a reading. And we said, well, where are you going? He said, I'm going upstream. Hey, don't be stupid. He said, I'm going upstream. And he went upstream, and guess what? He measured tritium going upstream. We were all gobsmacked. And we had to go back to our textbooks, and we realized what was going on is just what I said, this exchange mechanism was going on. So they were dumping it into the river, and as well as they're going downstream, they also went upstream. So the lesson is, tritium gets absolutely everywhere. Absolutely everywhere. It doesn't stop. As I said, the only place where it doesn't go through is steel, about 5 centimeters thick, stainless steel, and glass, about the same thickness. Everywhere else it goes. So that means you try and avoid tritium like the plague. And whenever you have to deal with it, you start worrying. One of the things they will say to you if you were to raise this, yeah, but the concentration levels are low. And you say, true, but we don't know, we haven't got a good handle on what the risks are, even at very low concentrations. The thing is that, do you remember the DNA molecule that I showed you? It has a protective hydration shell around it to protect it from rude shocks and chemical injury and physical injury. And it's water, basically, in a gel. So that when you have tritium intake by breathing or eating or absorption or drinking, this tritium can get next to the DNA in the water hydration. And the DNA, the tritium that gets to the DNA, then it's no use asking what is dose-risk relationship. It goes off the scale. It's very dangerous indeed. So the question is, does tritium get next to the DNA? Well, we don't really know. We haven't got a really good handle on where tritium goes. We think it goes throughout the whole body. So does that mean that tritium at very low levels could be dangerous? Yes, it does. It means we should apply the precautionary principle because we don't really know where it goes.
So why have the Environment Agency? I mean, I speak from civil servant myself.
You were there yourself?
No, not there, no, but I spent some work, I was in civil service, so I know all the shenanigans that go on in committees, what have you. But I'm interested to know, I didn't go to the public debate down the road at Corby, which I think ran for some 6 weeks. And we have lawyers for both sides who are talking about this. I don't know what was said about this, was tritium. Was that ever mentioned? Did it was mentioned? Why did the Environment Agency, did they bring this up, Environment Agency? They're quite happy to pass legislation for this dump to go ahead. And to be told that the waste is being, I don't know whether that's fact or not, the waste is being put into plastic bags, beggars belief. Is that correct? Have you got actual evidence that it's been put in bags?
Have you visited
You've got
the site?
photographic evidence?
Show you.
You have.
If you go up there, I'll show you.
I'm going to be really rude here and mention I've got a couple of minutes more to go. The guy who offered me a lift, where is he? We're ready to go in about 3 minutes, okay?
Okay, right.
I'm sorry about that. I'm going to answer your question, but if you guys would like me to come later in the year and give you a talk about tritium, I'm the person that you should speak to.
We would like you to come to the inquiry, actually, which is taking place next week, and give evidence in front of the government inspector.
Yes, please.
Is the new
Because
MP
well, how
going
else
to
can we fight? You know, because we're powerless really without yes. How else can we deal with this? Because it's it's almost a foregone conclusion.
I don't feel any emotional pressure.
So who's the chairman of your group? Chairperson of your group?
Chris
Down
is
over
really
there.
the main one.
You are.
Not really, Chris is the main.
You're right.
Well,
Yeah, you're trying to.
I'll have a look at my diary and see if I'm free.
We'll have a chat about it in the car,
You had a question?
if you want to meet your train.
Yeah, it could be the second done question of the night, actually. It's just a technical thing. You talked about the measurements that you use is
Millisieverts.
Yeah. I've not heard that expression before.
Millisievert.
Mm-hmm.
Milligray?
I'm not a scientist.
Oh.
I just need pictures. I've only ever heard of becquerels. What's the relationship? Is it like 1 to 100 or
That's
something?
radioactivity.
Okay.
A becquerel means if you've got a radioactive atom, it means it disintegrates one in a group of atoms. If you have a lump of material and you have 10 disintegrations per second, then that means 10 becquerels. Disintegrations. When you have a nuclear disintegration in that just pile of material, and that disintegration gives off energy, and that energy is called radiation. And you measure the radiation in sieverts, not becquerels. Becquerels is a rate of radioactivity. Okay?
Is there a linear relationship between them?
No. You have a risk factor which relates, for every different radionuclide, there is a different risk factor.
Right.
Plutonium has got a very high one. Cesium's got a high one. Strontium does. Guess what the lowest one is? The lowest dose for disintegration is tritium. And it's bananas. It's completely wrong. I'm going to swap this down.
The reason for asking is that, that most of the science has gone completely over my head tonight. You've expressed it very well.
I understand.
But for people like me, it's difficult to grasp. And if you want to, my assumption is that in situations like this, we need to simplify, almost make the argument ultra crude. One argument that I had heard a long time ago was a simple expression of risk in relation to background radiation.
Uh-huh.
And that's the reason for asking the question about becquerels, because the soundbite that I picked up was background level of 6 in Cornwall, and they want to dump 2 up here, so there's no problem.
6.1.
Becquerels. It's
I got a big idea they're talking about tritium.
Well, from what you've already explained, it's not as simplistic as that.
Well, put it this way. It's true that in many areas of the world, our background levels of 6 becquerels per litre of water of tritium exist naturally. And they're saying, well, we're only applying 2. Well, that's wrong. You shouldn't. The thing is that you can, depending on where you go, if you go far enough away from the nuclear installation, you can get down to 0.01 becquerels per litre. Depends where the measurements are. Put it this way, when you're dealing with people who work with the nuclear industry or radioactive dump industry, you've really got to know what you're talking about. Because you're going to fight with these people and mix it with these people, you need to know what you're talking about. These guys, they know that they're dealing with lay people. So you guys need some strong people on your side. And I've just talked myself into the camera.
And on that note,